All right. Welcome, everybody. Happy Thursday. Thank you all for joining today. It is a privilege to see all of you here. My name is Sean Odell, and I want to welcome you all to Container Management Best Practices in the Defense Sector. This is a new approach. This is a really kind of a first for the team here at Portainer. We typically focus on a series of making the hard easy. We've talked about GitOps. We've talked about a variety of other subjects. But today, for this webinar, this is the first time we are focusing on a very specific need and a very specific segment of our customer base. This is actually, if you read, and I'm obviously you did, the email that went out, our landing page for the webinar, this really came on the back of success and conversations with our defense sector customers and partners. And so hopefully today, as we get into this, some of the conversation, some of the topic will be very meaningful to you, very focused on what you're doing. And the other first is I'm trying out a new internet connection on a webinar for the first time. So who knows? Oh, and I also forgot to mention, I'm wearing a new Portainer t-shirt that's all black and all white. So, enough of that. We are glad you're here. What we want to do today is a few important things, and I'll say this first. Normally, I say this toward the end, before we actually get into the demonstration and some of the conversations. But feel free to leverage the Q&A. We want to hear from you. If you have questions, I'm going to do my best to address those questions throughout the session today. Adolfo, when he's in the middle of doing demonstrations, right, feel free to chime in. If you need something, I will do my best. I probably don't have all the answers. I'm happy to admit that. But we want to make this as welcoming to you, and we want to address your concerns throughout. So without further ado, here's our agenda. We have very simple introductions. I'll introduce Adolfo. I don't think he really needs much of an intro, but he is the star of the show. I have an interesting section. Normally, when we do these types of things, we have 5 to 10 minutes of dialogue, and then let's just get to the demonstration. But as I navigated this, I was even in a little bit of a conundrum of how do we navigate this idea of DevOps and shift left and trust zero and all of these other things, because it sounds like a lot of buzzwords. Sounds like a lot of things we all like to talk about, and maybe we hear and we attempt to explain. But I'm going to take a little bit of a different twist, and then Adolfo is going to do his thing, and actually show you some of the best practices and ways that we've been able to help our defense customers and defense partners to really accelerate container adoption, which is what we're about here at Portainer. So hopefully it works out. Hopefully you get something out of today's session. As always, Adolfo, welcome to the show, my man. How you doing?
Hey, thank you, Sean. Very good. And you? How you doing?
I have a little bit of a scratchy voice, as you could tell. So I apologize to everyone in advance. Forgive me if it sounds like I'm struggling through life today, but it is what it is. Adolfo, tell us what you do here at Portainer and a little bit about yourself.
Okay, well, thank you. I've got this nice, interesting title that is Sales Engineering Manager, but I prefer to present myself as the senior geek at Portainer. One of these senior geeks, right? That's actually my real operational title, if you may. So I engage with our customers, with our prospects, demonstrate Portainer. I'm also a product specialist. And just recently, someone gave me a nickname in the company called Crazy Horse. Sort of reflects a little bit of the crazy stuff that I do. But humor aside, the idea is to show you guys and everyone here, which, by the way, welcome and thank you for joining, what we can do in terms of the defense sector with Portainer. This has been well thought, and I hope to do a good showing, show you guys a bit of our magic here with our platform.
Awesome. And Adolfo, just so everybody's aware, Adolfo is in the front lines. He talks with our customers, our partners on a daily basis. And so the things that we're going to walk through today and talk about really come from the conversations he has. And so he is, there's no better person to talk to about this. So I'm excited for him to do that. So as I mentioned, just as we get started, normally we kind of have a little bit of a dialogue and talk through some of the things that we're going to discuss today. But what I actually decided on doing is, and I think I went through my section 5 different ways, 5 different times, and this is what I settled on, because when somebody mentions the word DevOps or DevSecOps or shift left or trust zero, or excuse me, zero trust, it often sounds like a chart that's super complex, hard to implement, and just where do I even begin? Right? We've all seen this kind of infinity loop. If you have not, just do a simple search for DevOps. There's like 9,000 different versions of it. Um, and this idea of DevOps or shift left and zero trust and SecOps and all of these things are meaningful and important. Look, I'm a techie. Don't let my title fool you. I've actually been giving conversations and talks on the subject for years now. But what about the practical implementation of this? And so I just wanted to show a couple of slides, having a little bit of fun with really some of the complexity, and I took them from a variety of different places. This one on the top left here is kind of my favorite because this is Microsoft. Nothing against Microsoft, but it's funny of just the different checks and boxes and steps and all of these things that you have to take. What I appreciate in technology is really just getting to the point and solving a problem. And so what Adolfo is going to obviously talk about, what we're going to show here in a little bit, is about solving problems. So one question for Adolfo, just kind of looking at these eye-numbing charts, as I like to call them. When you get into conversations with partners and customers around these areas, right? How do you take them from not being just buzzwords to practical, real-world implementation and living out these strategies? Can you
Yeah,
talk a little bit about that, Adolfo?
that's a great question. And what I like to do is really show them in practice these concepts with real life scenarios. And it's also one of the things that I hope to achieve during this webinar. I mean, it's not so much about the buzzword. It's a lot about getting that buzzword and translating that into like, okay, this is what this means, right? It's this feature or this step or this practice or so on and so forth, or this technology. And to the point where our clients, our partners go, oh, okay, now I get it. This is what you mean with X or Z. Yeah. So I think the most important thing about these methodologies or philosophies, whatever you want to call them, is really show in practice, right? What do you mean with this? I mean, well, how do you apply this in real life? Where does your tool or your platform really adhere to all of these concepts, right? And that's what I try to do as best as I can. Usually when I do a presentation or a demo, or even during our webinars, we've had, this is like the 4th webinar we've had together, Sean. You've noticed that, I hardly have a slide. If I do, I just jump straight into the demo and allocate, those concepts with, real life practice, right? So I think I believe I'm a strong believer in just showing the thing working as it is.
Yep. Well, and that's actually what caused me to reshuffle even my thought process for how to navigate today. Uh, I could have a slide that says, "Hey, here's what DevSecOps is, and here's how you have zero trust," and more from a philosophical, type of perspective, or an abstract type of perspective. But the reality is, every one of us, and every one of our customers and partners and community members, they have to implement this in a real world scenario, right?
Yeah.
I mean, I could sit here and say we solve threat models. Well, what? Well, okay. What does that even mean? Like,
Yeah.
we are here to help you, with whatever acronym of the day. And so what I wanted to do is really just articulate, hey, we are not about complexity. We actually can solve these things. Not to go beyond some of the verbiage, but the reality is, let's get down to actually showing our customers, and in this case, really where our customers have told us where we're solving these problems and helping them overcome them. So with that, I'm going to give one more slide and I'm going to turn it over to Adolfo. And so I actually had another slide where I was like, we're going to demonstrate SecOps and we're going to demonstrate GitOps. But I'm like, no, wait a minute. No, stop. Like I can't use buzzwords and not get to what we're actually going to talk about today. So when it comes to the practical side, here are some of the things that not only Adolfo is going to show, but this list came about because our customers, specifically in the defense sector, our partners in the defense sector, have told us this is where we're helping them. And so hopefully as we navigate this today, and I'm going to turn it over to Adolfo now, and I'll come back in a little bit and close this out. But once again, please take the time, ask questions, feel free. We're here to answer them for you. And if I can't answer, I will ask Adolfo or we'll save it for after the fact. Adolfo, it's all yours, my friend.
Cool. Thank you very much. And without building too much expectation, let's just jump into it, right? Okay. Well, thank you, Sean. Let's start with what I think is crucial in any scenario, but especially in the defense sector, which is access, right? Proper access. And what we do is we have in an RBAC engine here. I'm already going to start with connecting my Portainer instance in this demonstration is already connected to an open authentication backend. I use an open source one called Authentic. And the reason why I'm using this purposely in this demo is to show that you don't necessarily have to be tied to a cloud. I understand that in some scenarios, I've already worked in with some clients in the past in law enforcement that they required isolated environments. So the ability to work with environments and with solutions that don't necessarily depend on a cloud provider. So this specific authentication backend, you can run, for example, in a totally enclosed or isolated network, if you may. So this is why I picked Authentic. But Authentic is an OIDC compliant authentication backend. If you need to use a cloud provider, there's tons that also provide a type of a compatibility, like Azure, like Google, even GitHub has that. So so the first important thing, RBAC, right? What is RBAC? Role-based access control. So it's all about, with Portainer, showing not only a way to access your resources and your environments, also the way you deploy your applications. That also has to be part of the dev in this DevSecOps, in the security, right? In the DevSecOps, the security portion has to be very well implemented. Before I jump a little bit more into RBAC, I just want to show the interface. Here I have, I don't know, several environments here, like 10, 12, probably 15, all under one single Portainer environment. And there's a variety of things here. I have a couple of Docker environments, a Swarm cluster, several Kubernetes clusters, edge devices, and they're all connected to Portainer using several, like 3 or 4 different technologies. And I'll get into that in a minute. So I just wanted to show you that with Portainer, you can manage, in our case, officially, up to 5,000 machines in one single Portainer instance, right? So, and here I have, let's see, a license. I'm connected to 21. I mean, I still have a lot more to go. So, and they can be anything. They can be Docker, they can be Swarm, they can be Kubernetes, it can be a combination of all of them. And we can, with Portainer, you can manage all of these endpoints or environments, again, with one single pane of glass. But back to the subject at hand, how do you do this securely, right? Let me just bring, and I had promised I wasn't going to show any slides, but sorry, I have to show this one. This one is really important. I'm only going to show a couple of slides, but let me concentrate a little bit of the conversation here. What does Portainer do? Portainer is not only limited to access, I mean, okay, who can access or how can this be done by which user or team? It also manages the ability to work on the resources that you have on each of these environments, right? When it comes to Docker or Docker Swarm, the ability to manage RBAC with networks and volumes and registries. And that expands also into Kubernetes with namespaces and registries. In terms of deploying an application, also, I mean, container stacks, custom templates, GitOps, Helm, deployments, and we're going to see a little bit more in detail of that. And I'm also going to show you what I mean with this. All tied to any type of modern LDAP or OIDC compliant backend that you might need or want to attach, be that online or offline. We can do that. So RBAC is not just about, okay, I can access this given Kubernetes cluster. Is not only I can, but how, not only as a profile, but how in terms of the resources that cluster has and how I'm going to deploy the applications. Okay, I'm not going to spend too much time on the slide. It's just to give you an idea, a panorama of how important RBAC is in the tool, and we understand, especially for the defense sector. Okay, back to the Portainer panel. So it's not also important to have RBAC and enable access. It's also important to be able to understand who's going to do what. For that, we have 5 main roles. The first 3 roles are more administrative roles, if you may, starting with, the most top level role that allows you to do a lot of operations in your environments, be that a Docker Swarm or Docker standalone or a Kubernetes cluster. So it's the environment admin. And there's equivalent read-only role to this admin, which is the help desk. And there's this interesting one called operator. The operator is a role that allows you to manage starting and stopping containers and the resources around them in your environment, but doesn't necessarily, but actually this role will not be able to create or spin up containers, right? So this also came as a feedback from our clients. They needed a role that could just, start, stop, and monitor, but not create containers. So this is why we have this operator. So those 3 roles are more, again, administrative roles. And we have the last 2, standard user and the read-only user. The standard user is the day-to-day role that spins up containers, manages environment, his own containers or his microservices, his applications. And he does this obviously under whatever is defined by the admin. So it only has the privileges and access to resources that the admin allows him to have, right? And I'll show you what I mean with this in a minute. Okay, but that's not just it. We need to also be able to understand who logged in, where, and how. And what I mean with how. Portainer has several backends that you can use to connect to. One is always the internal backend for internal management of Portainer, but also the external authentication backend. And in my case, as I had mentioned, I'm using OAuth. So I know exactly who logged in, if it was successful, where the login came from, and at what time. But there's still more. We need to understand what each user is doing in the platform. So we have what we call the activity logs, or you can think of them as audit logs, that will audit everything that the user is doing in Portainer, right? This is not the application log. This is not where you're going to spin up as an application, be that a database or some other application. It's what's happening in Portainer, which is very important because you want to understand, for example, that in my case, user Delorenzo in endpoint called in the environment Portainer, he created an endpoint with TLS, etc. So this shows exactly what I'm doing. So if you need to understand, or if you need to audit every step that happens in the platform, we have this also available in Portainer. Finally, I also want to show our authentication capabilities. As I had mentioned, we can connect to any modern, well-known authentication backend like LDAP, Microsoft AD. These are very similar for those who have worked with these 2 technologies. And there's open authentication, which is the one I'm using with Authentic. And any OIDC compliant platform will work with this. So that's not only Authentic, it's also Keycloak, Okta, which are not here in the list, but there's also Microsoft, Google, GitHub, as I had mentioned. So a mapping of whatever user policy and team policy that you have in your backend is very easy with Portainer. I basically determine which are the groups and the teams I want to map in Portainer, and whoever is part of that team will be able to have access to Portainer. Okay, this is all nice. So this is access, right? This is here access. Now let's talk about resources. Let's say I want to make sure that I have a given team managing a given environment. Right. So I'm going to, let's say, manage the environment for Kubernetes K03 webinar. So what is this? This is a Kubernetes cluster, and I need to enable access to this Kubernetes cluster. So we're expanding this a little bit more, and I'm going to give this to a team called Dev as a standard user, right? So I created this access. Now, mind you, the interesting thing about Portainer is that RBAC is centralized in the sense that I don't need to do this per cluster, right? And what I mean is, if I change anything, um, uh, oh, I have to log out of the account. Sorry, I have to log out of here. Yeah, it's logged out. What this means is that these you don't need to do RBAC per cluster. Okay, let me simplify what I'm trying to say. If you've ever worked with RBAC in Kubernetes, I've always heard, and I myself have experienced, that it's usually something defined as minimal of a nightmare, right? Because you have to create several YAML files, define the services or service accounts that you want to enable access to, which role. Same thing goes for users. If you need to change anything, you have to roll back everything and redo everything. With Portainer, you don't need to do that. All you have to do is basically say, you know what? I need to enable access to this Docker environment to team called dev as a standard user, and I create access, and that's it. Dev team has access to this environment. Same thing goes to this, I don't know, webinar cluster. I'm going to go there ahead and say the same dev team, but in this case, we'll have operator access to this cluster, right? And that's pretty much it. So it's very easy to manage, and I can very also easily understand who's where and how. With my roles browser, I can see user James Smith is part of the dev team, and I see he's a standard user in the Docker environment, and he's an operator in the K8 Kubernetes 2 webinar environment. So, and if I need to change this, I can very easily go ahead and say, you know what, I need to change this. I can go ahead and click here and say, I want to change this to standard user and update. Now, what's the experience for a user? Let's go into another browser and log in as Jay Smith. And Jay Smith will have this experience. He's going to be able to go into this environment through the open authentication engine. And he has a totally different experience from what you're seeing from my main screen, right? He has access to this Docker and to this Kubernetes cluster. Now here, as a standard user, what can he do? Nothing. Why? And we're going to go into this layer of the RBAC, defining resources, saying who can do what. I've given access to a cluster, but I haven't really defined a resource that this user can play around with. So I need to give to this K2S webinar, and let me filter this a little bit here. Okay, I need to create a namespace and allow the team dev to work with this namespace. And now I'm showing you how easy I can do this. It's just click and go, right? And now I'm going to manage access to this namespace. I'm going to say dev team has access to this namespace. If I go back to the login as Jay Smith, and here it is, okay, it went from 0 to 1. So now Jay Smith or John Smith has a namespace where he can work around with and do whatever he needs to do in terms of deploying applications. Let me just pause for a minute. Let me make sure. Any questions coming in, Sean, from what I'm showing so far?
No questions so far. I think you're handling kind of the step by step, which is probably lending to a little bit of that. One thing I do have a question for you though. Right,
Sure.
obviously you're in a very particular Kubernetes cluster, namespaces across a single cluster, right? Um, Typical real world environments, multiple Kubernetes clusters, different scenarios here and there.
Mhm.
Obviously, same thing applies across multiple clusters. You can manage and support them appropriately. Correct?
Yes, yes, yes. Um,
Perfect.
So the thing about Portainer is our interface allows you to manage all of these different clusters. And let me go back to the admin interface so you can see what I'm talking about in a way where it doesn't really matter what Kubernetes cluster you're using, right? You can manage
Perfect.
all of this. And you see they're in several versions here. The first one is in version 128, then there's 127, 129, and variations, the 128 and the other clusters. So the experience with Portainer has to be secure, tightened, but also homogeneous and easy, right?
Yep.
Removing complexity. You see how easy it was to manage a namespace with Portainer, right? It was
Perfect.
just click and go, right? So yeah, behind the idea of using Portainer, we also have to make sure the interface makes sense for the end user, right?
Perfect. Thanks, sir. Appreciate it. If any questions
Yeah.
come up, I'll jump in.
Lovely, thank you. So RBAC. Now we talked about access. We talked about managing resources, meaning allowing a given user to be able to have access to a cluster and a namespace where he can operate and do whatever he needs to do. But I can also define internal registries. Now that we're talking about working in restricted enclosed networks, not only your authentication backend can operate or work in a restricted network. Also, the registries where you store your containers can also be enclosed in private, right? So here in this cluster, I can determine that my users are only going to use this given registry called registry.portainer.live, which is a private registry. It's not exposed to the public network or the internet. And as part of this given namespace test 000. Test 00, sorry. Now, if I browse the registry, I see I have a set of containers, and these are the containers that my user can work with, and that's pretty much it. He's going to be, he's only going to be able to operate and deploy applications based on what I have in here, right? And I can say, you know what? Not only that, I'm going to hide the public Docker hub so he cannot access the most well-known and most used registry out there, public registry, which is Docker. He has to use the registry I define in that given namespace. So you see, it's all about enabling the proper access to the resources, namespaces, and registries. Okay, and please, if you have any questions, if this is not, if this is too complex, just let me know. I'd be happy to explain any questions that you guys might have. All righty. So Jay Smith is here, and he wants to deploy, let's say a database, for example, right? Can he do that? He's only going to work with what I have within that registry. I know that in that registry, I have a database image, my SQL image. So I can just call this db00. I know the name of the image is Ubuntu, MySQL. Oh, let's do something interesting before that. Let's create a secret for this. What do you say? Let's create a secret for this database. I'm going to call it MySQL pass. And this is the key. This is the variable I need for the secret, which is the root access of the database. And it took me just a couple, I don't know, like 4 clicks to create a secret, whereas with a YAML file would be at least 12 lines. And this is keeping it simple, okay? So now let's go to our application and add this application. And you see, Jay Smith or John Smith can only work within this namespace. He can't do anything else other than what I define him that is allowed for him to do. I'm going to deploy this database, MySQL, and I'm going to select the secret. There it is. And I'm going to deploy, create a node port here. I know the database port is this, and click deploy. And as strange as it might sound, yes, I've just deployed an application with Portainer on a Kubernetes cluster with what, 10, 15 clicks? And it's already up and running, it's replicated. But let's check the YAML file. The YAML file has 106 lines. So what I did with 10 clicks is usually happens with only with 100 100 and something files. Now, mind you, when we say RBAC, we really mean it. You see there's a kubectl shell here. And let's say John decides to be smart and say, I want to check what's in this Kubernetes cluster. Let's see if I have access to this Kubernetes cluster. Let me try to get the list of all deposits running here. He cannot. So again, RBAC with Portainer is serious business. He's only going to be able to do whatever is given him in terms of access, and that is on namespace test 00, and that's the only thing he can see, right? So now we're talking about application deployment, right? Right here. So he's restricted from the very beginning in terms of access to the registries he can use, the namespaces he can have access to, and now the deployments or deployment that he can operate on. So he can only work with what is given to him in terms of access and deployment, right? Okay. So far so good. Lovely. Again, if you have any questions, just let me know. Alrighty, now let's spice this up a bit. What do you think, Sean? Let's throw some challenges here. Let's say, and we've heard this from our customers. Hey, Adolfo, what about a totally air-gapped environment in asynchronous management of environments? Can Portainer do that? Yeah, we can. We can. Well, let me show you. I have here this cluster 01. The IP address, and I hope you can see it. If not, let me increase the font here a little bit. Is 192.168.11.200. And this guy's got all of his ports open. Meaning it's an open cluster, and I can SSH into it. I can actually, with a proper config kubectl or kubeconfig file, talk to the API server of this cluster. So it's just there in the open. So basically, it's not secure, right? Now, let's say I do something malevolous. And here I have a monitor showing all of those ports I talked about, 22, 6443. Those are the ports that are used to access the node. And port 6443 is the API server of that Kubernetes cluster. Let's try to do the following. Let's try to close this. And what I'm going to run on this window here, first of all, I'm going to connect to the environment so I can run the command that will close my firewall. There you go. Alrighty. So now I'm going to just do something crazy. And you're going to see that here on the left-hand side, these two ports are going to close. I'm going to leave one open, which is 30778. 30778 is the port that I use to connect this Kubernetes cluster to the Portainer server. And it's TLS enabled. It's practically a VPN. So there's only going to be one single thread, if you may, of connectivity between this cluster and Portainer. And everything else is going to be shut down. So this is what I'm going to run. It's basically a firewall command that tells shut everything, just reject any connection, and just leave the port that I need to talk to Portainer. This is as close as I can get, and there you go. These ports are closed. This is obviously not a full air-gap simulation, Sean, but it gets as close as I can to it. Because in the real world, obviously this would be totally enclosed, physically enclosed. But given we're talking about a virtual environment, this is the best I can do. But I'll show you what I mean with this. And to prove myself truthful, I'm going to try to connect back again into that server, and I cannot. It's totally refused. The only port I left open is 30778. And this is the only port that this cluster has. So can I still manage this? Yes, I can. And I'm going to go beyond. I'm going to actually deploy an application, as crazy as I am, into this cluster. I can still talk to the cluster. I can still do stuff here. And I'm going to jump into another topic, which is GitOps. You will obviously see some failures because of the firewall restrictions, but that doesn't mean I cannot operate in here with this cluster. I can actually go ahead and say, you know what? I'm going to deploy, I don't know, let's deploy a tiny little application here. Again, I'm going to create a namespace. And why not? Let's try to deploy that same database with a form. Or should I just go ahead and do GitOps? What do you say, Sean? Should I try GitOps?
Well, I was going to say, go for it. Hey, this is your show.
Okay.
And while Adolfo's doing that, like one of the hardest things to do is to simulate an AirGap environment um, in a situation like this. The good news is though we have customers in a variety of sectors, not obviously not only in the defense sector, but working in very challenging scenarios, and so. Not just challenging from a connectivity, but also from a security perspective, and in this case, air gapped. So
Yeah.
I'm always enamored anytime I see customers do this type of thing. I think it takes me back to the days when I was on the customer side. So I love it.
Okay, so what I'm doing is I'm deploying, and this is something slightly different, which is part of the topics that we have in our presentation here in our webinar, which is GitOps, right? So I'm going to start merging things a little bit more. What I'm going to do is I'm going to connect Portainer to a Git repository, which again is a technology you can also host in an isolated environment. There are several Git servers and technologies there, like GitLabs or Git or Bitbucket, that you can host yourself. And connect Portainer to a YAML manifest of a cache server, a Redis server, but to this air-gapped environment, right? So I'm going to tell this cluster to connect to this Git repository, retrieve the YAML file, which is here. You see, I've got several things here, and I am going to spin up GitOps. Okay, let's talk a bit about GitOps. GitOps in Portainer is a very important feature widely used by our clients that enables you to automate and have better control over your deployment. In what sense? Git is a well-known versioning and control and development technology. So we're talking DevSecOps. We need to make sure that Portainer can also allow you to have access to tools that are important on the day-to-day routine or operation of any developer, right? And also, not only developer, but also sysadmins that, for example, need to store or want to store their infrastructure as a code or their deployment as a code in a Git repository, right? Because Git obviously has all those advantages of rolling back, of versioning, so on and so forth, branching, access, etc. So we can connect Portainer to a Git repository or a Git server, and we have two methods that allows us to pull and talk to this Git repository. The first one is via a polling mechanism. Every X amount of time that you can define, starting with 1 minute, Portainer is going to talk to this Git repository and check for any changes. And if there are any changes in your code and your YAML manifest, it'll do a Git pull, which is a Git synchronization, if you may, command, and apply the deltas and the changes that you have in your code. The other option is using a webhook, where you have more control. Basically, you're invoking this webhook in Portainer to do exactly the same thing. Go to the repository, check if there are any changes, and if there are, apply those to your deployment. I'll just leave polling for now. I'm going to click on deploy. I think I have everything I need. Okay, two more things before I go on. And in totally enclosed environments, obviously you don't have access to the internet or the public network. So you probably have self-signed certificates. So you have to make sure that you'll be able to use them. And this is something that we support here. You can use a self-signed certificate to skip the validation of your certificates and still connect to an internal Git repository. The other feature, which is also very important, is policy enforcement. We're talking about policy enforcement and management, which is the always apply a manifest. What does this mean? This means that if anything changes between the interval, which can be 1 minute or an hour or a day, manually into the environment, when Portainer connects to the Git repository, it's going to overwrite any of those changes. So it's a policy enforcement to make sure that your Git is your single source of truth, and that that's what has to be used for this specific deployment. Okay, let me click on deploy and see what happens. Okay, so it's deploying in namespace test01, and there you go. It was quite fast. The Redis cache server. But you know what? I need to change this. I have 4 replicas. I want to beef this up a little bit. I want to go up to, let's double it. Let's go 8. So here, what I just did is I changed my YAML file, and it's just the standard Kubernetes YAML file in my Git repository. And Portainer within that interval is going to identify that change within that minute and apply that to you. What's the importance of this? When we're talking about automation in a flow, I mean, you want to make sure that you don't have to redeploy your application all the time. Right? So this is part of the DevOps, let's say, scenario where you can have tools that enable you to see, and not security is not the word, but properly manage your deployment so without having to, rewrite the entire code, redefine the entire code. You just want to change a specific parameter. You don't want to redeploy the whole thing, right? This is where this comes in as an amazing tool for the DevOps or the infinite loop sort of that Sean was illustrating, the shift left, right? There we have it. This is like a real practical example of shift left. Let's just refresh this. There you go. I just refreshed the screen, and all by itself, it went from 4 to 8, right? And that can be any parameter in your YAML file. You need a rollback, just roll back on Git, and Portainer is going to get that back and redeploy whatever change you want. So mixing things a little bit when it comes to deployment and Git, this is just, actually, we've heard customers say, I'm dumping Argo CD. We're just going to use this because we don't need Argo CD anymore, right?
Hey, Adolfo, one quick
comment.
question.
Sure.
So in this scenario, right, obviously you're using GitOps. What if there was connectivity and communication challenges between assets? What would happen between that delta? And then if it comes back online, what does that look like?
Nice, very good question. Here you saw that I mixed a little bit of our topics, right? I did a Git deployment on the Kubernetes cluster that is, as we see here, totally enclosed. I cannot connect to it anymore, and it's secure, but I can still manage that. Plus, I can still manage RBAC into this cluster, right? But that's a good question. Let's say we're talking about a scenario where there's limited connectivity. I mean, what do we do in this situation, right? For that, we have a technology which we call the edge compute technology, right? And we have a specific agents to be able to connect to these environments that are what we say outside of your purview, outside of your network, at the edge, right? That's a concept. I see a question here.
There we go.
Oh, Terraform. Yes, we do. Actually, we do support Terraform. We don't have a Terraform. What would you call it? As a Terraform
provider?
Provider,
yeah, Terraform provider or module.
Well, but we do have a very open API that our customers that use Terraform use extensively to integrate Portainer into application deployment with the API. So, for example, with Kubernetes here, you'll see the amount of calls that you have are pretty much all the calls that you need to manage, deploy everything from a namespace to a Kubernetes cluster to the applications and deployments on this Kubernetes cluster straight with Portainer. So what they do is that they just do the API call with Portainer, a Portainer server, and use Terraform or even Ansible for this purpose.
Yeah, and I would also add here, this is a common question that we get. Do we support Terraform? Do we need Terraform? We've actually seen, as Adolfo mentioned, we do have customers that leverage it in this fashion, but we've also seen customers say, well, I don't necessarily need Terraform at that point. So, and look, if you want to use Terraform, that's your prerogative. We're all for it. But at the same time, we definitely have seen organizations and customers move away from that, especially because of the way we handle Helm charts and just some of the innate capabilities around GitOps and RBAC, that type of thing. So we're a fan of whatever scenario you choose. Obviously, we think many of our customers think it's better to go this route, right? It's up to you though, but we definitely support
it. Continue with your explanation, Sean. We have something which I like to call the Terraform Portainer, right? Which is the custom templates, right? And I wasn't going to show this, but this is a really, really cool feature, right? Custom templates allow you to define. Let me show you something. So I've got this application here. Let me go to Redis, and I'm going to convert this to a template. Okay, I've just converted. this application into a template. What does this mean? That now I have repeatability. I don't need to learn a new language. I can just use YAML. And I can even, I can go beyond. This is Redis. Let me just Redis. I can empower this tremendously. You see there's RBAC here. I can define who will have access to this custom template, be the administrators or specific team. And I can put in roles here that allow me to make this even more powerful. In what sense? In the sense that the end user, when they use this, when they access a custom template, they can deploy their applications and they can define certain parameters that you can enable this for the user using the bracket variables, or some people call them mustache variables. And I can put as many as I need here in my custom template. And I create this custom template. And when the user accesses this custom template, the experience is the following. He's clicking it, and he's got these two template variables he has to fill in, and boom, that's it. So a lot of our customers, especially for application deployment, not for infrastructure deployment, for that we don't do that, but for application deployment, microservices, pods, and deployments, they use custom templates extensively, a lot, right? So that might be something you might want to take a look at, and we'd be happy to go through this in another call with you guys. Okay, so back to Sean's point on restricted, or what I said, challenging access of environments, right? When there's no connectivity or there's very limited connectivity, how do we deal with this? Okay, for that, I was explaining we have our edge agent. Let me go into this screen here and show you all of the environments I have connected to this Portainer instance. Some of them, the first one is my Portainer server. So I'm using the socket to talk to the Docker environment that's running the Portainer server. And a lot of them have an IP address. Now, some of them do not have an IP address at all. What is it with these guys, if you may, right? These are environments where I have no idea where they are, right? I don't know where they are. I don't need to know. I don't want to know, or just can't know where they are. Given, for example, their geographical location or the nature of the environment that's being managed. And when we say edge, we say, again, everything that's beyond your network or your purview, or whatever you can see in terms of access and control. It's outside of your network. But we allow you to manage these environments, as I had mentioned, 5,000 machines with one single Portainer instance, by basically inverting the way the communication is established from that environment to the Portainer server. So let me be a bit more practical here. Let's go back to our dashboard, and let's say I want to, and then here I have, within the edge environment, I have two ways of connecting to these environments. There's a synchronous and asynchronous. So if I click on the, I should say synchronous, sorry, it says asynchronous, but it's synchronous actually. If I click on this environment, it's a Docker machine. I don't know the IP address. I can still connect to it, and I can manage this environment. I can see what's running, etc., just like you saw with a Kubernetes cluster or any other environment. But let's say I don't have a guarantee of connectivity. Then we come with the asynchronous option, which is a way to connect in an asynchronous manner by snapshots to this environment. And here I can see within the interval of the snapshot, or whenever this environment connects to Portainer, what's happening here, right? We leave it as low as possible, 1 minute, but you can have a scenario where you have a moving a vehicle that doesn't have 100% coverage, and only manages to connect to the Portainer server whenever, obviously, that coverage or that link is established. And once that happens, that endpoint, in this example, this Docker environment, is the one that initiates the communication with Portainer. So here, for all of those that have an IP address, what's happening is that Portainer is talking to them. and he's managing this communication. For those that do not have an IP address, it's the other way around. That endpoint, that Docker environment, or that Kubernetes cluster is the one establishing the communication with Portainer. So again, if you don't have coverage, if you're in a very low latency network or tough environment to have access to, you can still manage containers with these environments. And I'll go beyond that. The asynchronous agent not only allows you to connect to these environments that have very challenging connectivity, but also they can be their firewall can be totally closed. The only thing that they need to have is outbound access to port 443, which is HTTPS, so that they can initiate the connectivity, the talking to the Portainer server, and they're the one through that port 443, which is a secure port. Everything happens, right? Let me show you in practice, practically what I'm saying. So I have this edge group, which is where I throw my environments or my machines or my Docker machines or Kubernetes clusters. I have them grouped in here in this edge group. And now I can associate a stack, which is what's going to be deployed and or if you may, the payload that's going to be sent to these environments. I can create a stack, and again, the stack can be connected to a Git repository. You can have GitOps, or you can just copy and paste it here. In this case, I'm just going to copy and paste it to make it easier. I'm going to pick a tiny little one called Who Am I? This is just a tiny little demonstration container. And once I click, let me give it a name. Obviously, I give it a name, Adolfo, otherwise it's not going to work. Who am I? And I define, okay, this is the group to where I'm sending this payload, right? You can have multiple groups. The name can be arbitrary. It can be defined however you want. And once I have this defined, I say, this is what I'm going to send to this group of machines in this edge group. Again, I have other policy enforcement. I have pulling images, pre-pulling images in the case of very restrictive networks where you can't pull an image. So that's, again, done through that kind of connection between the endpoint and Portainer. If you have a private registry, you can define a private registry to be able to access a container that's in a private registry, so on and so forth. There's tons of options here. I'm not going to go through all of them, otherwise we're going to spend another hour here. But I'm going to deploy this stack. So what's happening? Portainer is talking to two environments. One is synchronous, and this is this guy down here. And he's telling him, you have to deploy this little application here. There you go, 2 containers. It's deployed. And it's here. You see this the little cog running. And on this guy, it's going to wait until that connectivity happens. That connection is established. And once it's established, then Portainer is going to manage and deploy that container. For now, it only sees one. But in roughly a minute to 2 interval, we're going to see that this is going to get updated, and we can manage that container there. So this is amazingly, this is really, really cool. And I'm going to talk a little bit about some use cases of clients that we have that use this type of technology and how they use this type of technology. Sean, you're going to say something?
Yeah, we are almost at time. I know
Okay.
you're in depth here, but I'm going to let you close out in give me 1 minute after. We'll be good to go.
Cool. So let me talk a bit about those use cases while that's happening in the background. We think of the defense sector with at least 3 pillars that are very important, right? Mobility, precision, and reliability, right? I mean, that's key. It's an industry that works with mission critical operations. If you don't have the ability to be mobile with precision and with reliability, I mean, you can't get anywhere, right? So we have 3 use cases here of clients that have similar, let's say, view to these 3 pillars. Transastra is actually a government-funded company that mines visually asteroids in space, right? And they're using that edge connectivity, the asynchronous edge connectivity, to connect from their base to the satellites in space. So we're actually, yes, we are Portainer in space. We are running in space in satellites with that edge connectivity technology. US Gypsum, they fabricate these drywall panels, and they go through a very very important process of quality control on these panels. They have these machines that can check for nano bubbles in these panels. And if something goes wrong, they stop their production line and they do all their quality control, etc. Now, that is managed, all the back and forth updates of their machinery and the calibration of those machines are done using containers with Portainer. So when it comes to precision, they rely 100% on our platform to be able to manage the machinery and all those sensors that need very high precision and in a way mission critical operation to be able to operate and produce their products, their panels. And reliability. Now, this is also a really cool use case. Ferrari, the Scuderia Ferrari, the one that goes around the world in the F1 races, they have a mobile data center, which is actually, it runs in a physical container, right? Curiously. And in every event, they synchronize this mobile data center with the one they have in Italy, in Maranello, in every event. So that is done 100% using our edge compute technology. So when it comes to business continuity and reliability, we're also there allowing this to happen in all these three use cases. So I just wanted to point that out, that this is where we are in those three pillars, and this is how we do it. Let's go back to Portainer quickly, Sean, let's just see if, oh, there you go. The asynchronous agent connected, and I see that it's running that little deployment successfully.
And you met the demo requirements within time. If you don't mind, I'm going to close this out. Go back to that slide if you don't mind.
Which one?
I always laugh at this with the three different pillars and our three different customer tiers. So clearly, we were not going to get on here today and actually spill out some of the defense sector scenarios that we are currently deployed in. Clearly, we're not going to do that on an open webinar like this, and so we wanted to be very careful. But we definitely can and have conversations in and around that area, obviously with our partners and so on. We're willing and able to help you navigate different scenarios. There's one final question, and I'm going to close this out. Can we consume Terraform objects deployed with Terraform? Absolutely. Yes. We could definitely do that.
There's two more questions.
And go for it. You can answer Kyle's question. Go for it.
Kyle, you can, via the API call, do the entire process of having Portainer your Git repository via Terraform. Right? So you just you put that in your Terraform pipeline to make sure that the API call from Portainer talks to the Git repository. And once it's established with the proper parameters, be that via webhook or be that via the polling, carries on all by itself.
Yep. And with that, we are at time. And feel free. We'll actually follow up with the recording of the webinar, post this event. You'll probably see it in your inbox the next early next week. We look forward to supporting you and your teams on this journey. We understand how important and sensitive all of these areas are from a defense sector perspective, and we're willing to work in that with you all. So, as always, thank you for attending. Without you, these are not a success. Adolfo, really appreciate your time, good sir.
Thank you very much. Thank you, everyone.
Cheers, everybody. Have a great day.
Cheers. Bye-bye.